Good morning, my dear students. I welcome you to NEET World. So in this session, we will be discussing the continuous to the last class. So where we have discussed haloalkanes in the last session, right? So we will continue with that. So using top 15 PYQs, we will be completing this chapter. Okay. So now in the last session, I have given few questions as a homework, right? I hope you are already solved those questions. If not, I am going to explain those. Okay. So first of all, before going to the session, I just wanted to announce you about our new long-term batch, which is going to be started from July 1st. Already started it is. Okay. So as of now, we are discussing basics. So if you are looking for a best long-term course for NEET and JEE 2026, so this is the best option you have. Okay. So for more detailed information, you can contact to the mobile number which is scrolling on the screen or which is provided in the description box. Okay. So let's begin the session with questions which I have given as homework. Yeah. So look into this. The major product formed in the given reaction is. So this is JEE Main 2023 question. So try to answer this. Yeah. So the given substrate, if you look, what is the reactive site? See the reactant here it is given, like reagent given here it is anhydrous AlCl3, right? So anhydrous AlCl3 is a Lewis acid. So now what is the reactive site that can react with this Lewis acid? We need to identify that first. See here, chlorine has lone pair electrons on it right now, and then next oxygen on this methoxy group also having lone pair electrons on it. Okay, but if this oxygen reacts with this, we will get a highly unstable phenyl carbocation, which is highly unstable. So therefore it won't participate in the reaction. So now this is the one reactive site we have. See, chlorine have more affinity towards this AlCl3 as it has lone pair electrons on it, and aluminum has vacant orbital. So to this vacant orbital, the lone pair electrons of chlorine is donated. Okay, so we will get a complex like this. Write it as it is. NO2. So how many carbons are there? 1, 2, 3, 4. 1, 2, 3, 4. Okay, just put that 4 number of carbons. Yeah. So here one methyl group. So this chlorine forming bond with this AlCl3. Okay, since chlorine is donating its lone pair electron, it should get a positive charge because the electron deficiency decreased on the chlorine you can consider, and aluminum getting more electron density as it is gaining electrons from the chlorine. So this is how you need to write first. Now if you look, we know this is a carbon atom here. So bond, sigma bond between this carbon and chlorine, and here we have chlorine and aluminum, one more sigma bond. So now we need to look for the like weakest bond here. See, the affinity of chlorine towards this aluminum is more, therefore the like this chlorine, since it is more electronegative, drag the bonded electrons towards itself from the carbon and creates positive charge on this carbon. That is what electrophile is created within the substrate, right? Write that molecule first. Yeah. See, from here I have removed chlorine so that this carbon should get what? Positive charge. As it is having only 6 valency electrons in it, so I can say that is electron deficient now. So now look into it. Since this is electron deficient intermediate, okay, we can say carbocation. So now how the reaction proceeds further? This is what we need to think here. See, we have a methoxy group and here we have a nitro group. We know nitro group is strong electron withdrawing group, right? So it will withdraw the electrons towards itself from the ring, whereas methoxy group having lone pair electrons on it, oxygen lone pairs will be donated into the ring and increases electron density in the ring, right? So now when these electrons from oxygen is donated into the ring, creates negative charge, it means electron density ortho to this methoxy group, that means at this position, or para to this methoxy group, it means this position, right? So these are the positions where we are seeing more electron density, and this is the position of carbon where we are seeing more electron deficiency. Since it is electron deficient, now it is looking for electrons. So we have electrons either ortho and para. Since there is less electron like repulsions at para position, therefore the ring formation takes place, this donation of electrons from para position to this. Now we will get a ring cyclic ring formation takes place. Look here, so 1, 2, 3, 4, 5, 6 member ring is formed. See, there are some options containing 6 member ring in the given options, right? So we can go with that option, and this is our perfect approach. Okay, write the ring first. Yeah, so like this, see I am numbering it. So take 1, 2, 3, 4, 5, 6. Okay, so we got a 6 member ring here like this. So 1, 2, 3 like this, you can count 6 member ring we got. On 6th position, 6th carbon, we have one methyl group. So write that methyl group here. Okay, up to here it is clear, I hope. So what I did, see I have donated these electrons, these pi electrons from here. So if you observe mechanism properly, so this is how we have electrons now. So these electrons are donated like this, yes or no? So that we will get a compound like this, and here see if you observe this properly, we have double bond here, this is donated. So this carbon will get positive charge, and here we have hydrogen. Now this ring, aromatic ring, lost its aromatic nature. It is becoming non-aromatic. So in order to regain its aromatic nature, the hydrogen from here it is removed, so that we got a benzene ring or aromaticity of that particular ring back to it. Okay, so that we have like this, answer something like this, methoxy group here, double bond, double bond, double bond here, methoxy group here, and nitro group here. Okay, hope this is clear. So this is our answer. So you need to look into the options which is having option like this. See, we have 4th option similar to this, yes or no? See, we have 4th option, so that will be our answer for this question. Hope it is clear, and if you have any confusion, please write in the chat box, I will be looking into it. Yeah, so one more thing, what is the mechanism involved in this? So what is the name of that mechanism? See, first step we have generated electrophile, the next step attack of electrophile and formation of sigma complex is taking place, and third step is what? Deprotonation taking place here, right? So these are the 3 steps involved, and in the rate determining step or in the slow step, what we have seen? Electrophile formation, right now. So electrophilic substitution reaction is taking place. So one H plus is substituted, removed, and that will be replaced by one electrophilic carbon. So I can say it is electrophilic substitution reaction, and it is taking place in benzene aromatic ring. So we can say aromatic electrophilic substitution reaction. Hope this is clear, right? So let's move forward. Yeah. So now based on this, I will be giving you one homework question. So take a screenshot of it if you require. Yeah. So try to solve this question. Very basic question I am giving. So I have toluene here. So you need to react this with AlCl3, anhydrous. Okay, anhydrous AlCl3 I have given. So what is the product formed here? Okay, so you can tell me the name of that particular product formed in this reaction, and this is one reaction. So I just wanted to explain one more question based on this Friedel-Crafts acylation and alkylation based question. Yeah. So take the benzene ring again. Okay. So here I just wanted to take a compound having acyl group here, and this side it is having chlorine. So if this part is involving in the reaction with anhydrous AlCl3, we will get alkylated product, because if this chlorine is removed, so this is a carbon joining on the this benzene ring. If this chlorine is involved, so acylation taking place. So we need to understand which one will be favored here, acylation or alkylation. In Friedel-Crafts reactions, so when acylation and alkylation both are possibility are there, then you have to go with acylation, because when this chlorine is removed from here, see both are chlorines only, both have same like reactivity towards it, but when this chlorine is removed, the respective carbocation generated, the acylium ion generated here is more stable when we compare with this carbocation, simple alkyl carbocation generated here by removing this chlorine. So that's why, since acylation, like acylium ion is more stable, so acylation takes place readily in these Friedel-Crafts reactions when compared with the alkylation. Okay, so therefore this chlorine you remove and put the remaining part on this benzene ring. So what is the remaining part? Yes, this is our product. Hope this is clear. So always remember, acylation takes readily when we compare with alkylation. Yeah. Yes. Hope it is also clear. Let's move forward. Yeah. So look into this. Number of moles of AgCl formed in the following reaction is. Yeah. So now we have like halogenated compound here, substrate. So we need to treat this with AgNO3 so that we'll get a product A, and along with that AgCl precipitate also formed. Now how many moles of AgCl precipitate is formed? That is what our question here. So you need to explain, you need to give the answer that how many number of moles of this AgCl are formed here. So it means how many reactive chlorines are there in this substrate you need to identify. Right now, so chloride ion when treated with AgNO3, so what happens? This Ag plus ion, chloride and Cl minus ion forms AgCl, which is precipitate here. So now where do we have this highly reactive chloride ions in the given compound? This is what you need to identify here. So now if you look at this chlorine atom here and this chlorine atom here, see, we know carbon, chlorine, we know chlorine is more electronegative. So if this chloride ion comes with these electrons, this chlorine atoms comes with these electrons as a chloride ion as a negative charge, the carbon gets positive charge, which is a phenyl carbocation, which is highly unstable, right? Therefore the chloride ion will not comes out easily. So this is inert chloride ion, I can say. It will not form or it will not show reaction towards this AgNO3. So there is no reaction with this. Hope it is clear. Now let us look into this, then we will come to this. Yeah. So if you look at this chlorine, so since we know chloride ion is like chlorine atom is more electronegative, it will take these bonded electrons towards itself, creates a positive charge on this carbon, and chlorine will goes out as a chloride ion. So this chloride ion can form precipitate with this Ag plus ion to form AgCl. Yes, because the respective carbocation generated here can be stabilized by the ring pi electrons. So we can say this carbocation is benzylic carbocation, which can be stabilized by this benzene ring electrons. Like see, we have like electrons like this now. So this will stabilize the carbocation by resonating structures. Hope it is clear. That's why this chlorine will involve in the reaction, but not this chlorine. Up to here it is clear, right? Next let us move into this chlorine atom. See, if we remove this one, we will get a positive charge on this double bonded carbon. sp2 carbon, which is electronegative carbon, because hybridization is sp2, having more electronegativity or having more s character than the sp3 carbon, right? So therefore the positive charge on this double bonded carbon, triple bonded carbons are highly unstable again. Therefore this will not goes out. And you know one more thing, here we have lone pair electrons on chlorine now. So these lone pair electrons will be in conjugation with this ring pi electrons like this. Therefore it will also shows strong affinity or strong bond towards this like carbon atom. Okay, vinyl carbons, vinyl halides will not show reaction towards AgCl or AgNO3. Okay, as well as phenyl chlorides, phenyl halides also will not show reaction towards AgNO3. They will not form precipitate. Hope it is also clear. Now look into this. So if I remove this chloride ion, so we will get a tertiary carbocation. It can be stabilized by this alpha methyl hydrogens, and here also we have 3 methyl hydrogens on this methyl group, and here we have 2 alpha hydrogens with respect to this tertiary carbocation, right now. So it will be stabilized by 3, 3, 6, 7, 8 hydrogens, alpha hydrogens are there, 8 hyperconjugative structures are possible for this, right now. So it will be more stabilized carbocation. Therefore, what are the chloride ions that can precipitate with this AgNO3? So this benzylic chlorine and this tertiary carbon containing chlorine, right now. These are the 2 chlorines only will form AgCl precipitate when we treated with AgNO3, but not this vinyl chlorides and this phenyl chlorides. Okay, so your answer should be 2 AgCl. So you can, your X value is how much now? 2 you can keep here, that's it. Hope it is also clear. Medical zone in the chat box, hi dear. So just follow the class. If any confusions, please feel free to ask. Yeah, so now tell me, here I am writing one more question. So just give a try. So A, B, C, D. So one more option I am adding. So one last option, one more. Yeah. So tell me, out of these A, B, C, D, E options, so what are the compounds can form precipitate when treated with AgNO3? It means precipitate means what? This Ag ion from here and the chloride ion from this respective compounds should combine to form AgCl. That's it now. So in order to form this, what we required from this? We required chloride ion from these 5 options. So which will give that chloride ion when we treated with this? Yes, this is my question. I want answer for this particular question, like what are the options? Whether C forms precipitate? Yes, you can tell me C in the comment box, and if D, and D in the comment box, and if E, and E in the comment box, like multiple selective answer, like more than one answer I have given. Okay, so tell me with a reason, you can tell me. Yes, then next let us move further. Yeah, so this is one of the most important reaction, just look into it. So especially we will see in JEE mains this kind of questions, and even in NEET also. Just look into here, the product formed in the reaction. Say they have given a substrate and one nucleophile is given here. So we need to give the appropriate product possible in this reaction. Look into this question first. What kind of groups are attached on this benzene ring? Look here, we have nitro group. So nitro group is strong electron withdrawing group, right? So they will withdraw the electrons towards itself from the benzene ring like this, right now. And now what is the charge created in the benzene ring? Yes, it is creating positive charge in the benzene ring like this. Okay, so now what are the positions it is creating positive charge? At ortho, it means adjacent position to this nitro group at here, as well as it also creates positive charge this side also. This is also ortho position, and along with that we have one more position. See, this is the positive charge containing position, that is ortho. Now we are saying, now if these pi bond electrons shift here, we are seeing positive charge at this position, the 4th position with respect to nitro group, 1, 2, 3, 4. So this 4th position is called what? Para position, right? So we are seeing electron deficiency due to this electron withdrawing group at ortho and para positions. Since we have electron deficiency at ortho and para position, and now our nucleophile given here is alkoxide ion, OR minus. So this electron rich species will attack this electron deficient site. Now tell me which is appropriate site to attack by this nucleophile? Yeah, that is what we need to understand here. See, I am taking the substrate once again here. Yeah, so now it is creating positive charge at this position, I told you now. So this will now attacks on this positively charged position here. Okay, so that we'll get a compound like this. Like this. Okay, so after getting this, now again this O minus will be given negative charge into the ring. So now you can look back. So here the pi electrons moving into its original position, so one of this group should leave. So we know concentration of OR minus is more here, therefore it will not leave. So fluoride ion will goes out as it's more electronegative, drag the sigma bond electrons with itself and goes out. Therefore we will get a product like this. Yeah. So this is our product. So what are the things we have seen? One nucleophile is coming inside and another F minus, like F minus means what? Electron rich, that is what? Nucleophile. And one nucleophile is going out. One is coming in and one is going out. So we can say this is a substitution reaction now. See, one is substituted by another. So we can say nucleophilic substitution reaction, and it is taking place in aromatic rings. So we can say aromatic nucleophilic substitution reactions. Okay, hope it is clear. Now tell me, where do we have this kind of options? See, we have in option number 1, we have not in option number 1, just look. Yeah, so option number 1 is our answer. See, nitro methyl group and OR group. So what is our option? So option number 1 is perfect answer for this question. Hope it is also clear. Now I will be giving you one more question. Chlorine here and here one more chlorine. Okay, so high temperature, and here I am mentioning some nucleophile like OR minus itself, OR minus. Okay, so tell me where the reaction takes place, which chlorine will displaced out of these two, which will be displaced by this OR minus, or which will be substituted by this OR minus, either this A chlorine or B chlorine. So tell me A or B in the comment box for this question. Yes, let's move forward. Yeah, so again, which are the following is most reactive towards ARSN? ARSN means what? Aromatic nucleophilic substitution reaction. AR, aromatic, SN, nucleophilic substitution reaction. So which is more reactive towards ARSN? So those compounds are more reactive which contains more electron withdrawing groups in it. Yes, so out of these 4, which is having more electron withdrawing groups? See, 3 nitro groups are there here. So 3 strong electron withdrawing groups are there, and those are ortho and para position to this living group chloride ion. Therefore, it will be more reactive when compared with the other 4 options, other 3 options. So which is more reactive in this? So I can write a statement: electron withdrawing group containing substrate, electron withdrawing group containing substrates are more reactive towards ARSN type reactions. Okay, so it is containing 3 electron withdrawing groups, therefore 4 is more reactive when we compare with the others. Now I am asking you to arrange, see, for this particular question our option number 4 is perfect answer. Now I am asking you to arrange them based on their reactivity order, which is more reactive and which is the least reactive. I want order for this. Yes, anyone in the chat box? Yeah, 4 containing 3 electron withdrawing groups now. So 4 is more reactive. After this, to this chlorine, see, 2 electron withdrawing groups are there. So 3 first, 2 next. Yes, after this, here we have nitro group, here also one nitro group is there. But we know electron withdrawing groups like nitro groups, decreases electron density at para positions and ortho positions, but not at this meta position, not at this third position, right? So if you look into this option, nitro group is electron withdrawing group is present, but this is meta with respect to or third position with respect to chlorine. So therefore this, in this option it is least reactive as there is no positive charge creation on here with respect to mesomeric effect of this nitro group. So third one is least reactive, so in this first option. So this is the order of reactivity. Okay, hope if the based on the level of exam they may create like single answer type question, like just asking select which is more reactive, so you can go with fourth option. If they ask you to give the order of that, you have to give it like this. So if you are clear with the concept and approaching or application of the concept properly to the questions, you can do any kind of questions based on those concepts. Hope it is clear. Now anything to be asked? Yes, nothing. Yeah, so tell me what is the major product for this reaction? See what is the reagent given here? Alcoholic KOH under heating condition. See alcoholic KOH means here we have OH minus and K plus. Under heating condition means definitely dehydration takes place. Heating is there now, so you can like you can think for dehydration reaction, elimination of water takes place. So now here if you observe in 4 options there is no chloride atom or chlorine atom in the 4 options. So it means definitely this chlorine has to be removed from here, and I told you H2O should be removed. It means we have OH minus, so one more H plus is required. So this H plus and chloride Cl minus has to be removed from this, therefore we will get one of these options. So I can say this is an elimination reaction. Okay, we are eliminating chloride ion and we are eliminating H plus proton from the given substrate. So I can say it is a elimination reaction. So how the elimination reaction takes place? See here we have chlorine, I can say this alpha position with respect to chlorine or alpha carbon. Okay, the adjacent carbons to with respect to the chlorine attached carbon should be considered as beta, right? So these are beta carbons. Okay, let me zoom it out. Yeah, so beta carbons. Now on these beta carbons we have hydrogen over here and 2 hydrogen over here. Okay, so from this base we have KOH, means it's a strong base, abstracted proton from here. So which proton will be abstracted? Most acidic proton will be abstracted, and that should generate a more stable alkene. So therefore it will abstract a proton from here and will get a double bond here, and this chloride ion goes out like this, and we'll get a product something like this. Like this. Okay, so what are the other possible product we have? See, this is a beta proton, and this side also we have beta protons. Now you can remove one proton from here, you can get a product like this. Like this. Okay, but out of these two they are asking major product. So always remember, the more stable or internal alkenes are more stable, those alkenes are formed. So what I am saying, most stable alkenes are formed as a major product. And how can we identify which is more stable? Internal alkene should be considered as more stable. Why? Because it has, see, to this double bond, here we have methyl now. So these 3 hydrogens will be participates like hyperconjugation with respect to this double bond. Okay, and here also we have 1 alpha hydrogens, and along with this the extra important thing we need to discuss is mesomeric effect or resonance of this ring pi electrons. See, the pi bonded electrons of this benzene ring is in conjugation with this pi electrons. Therefore that makes it to be more stable substrate, more stable product when we compare with this isolated double bond. So I can say this is major and this is minor. Okay, so these internal alkenes are more stable alkene formed here is also called as Sajoff product, and this less stable alkene or terminal alkene also considered as Hoffman product. So instead of asking major minor, they may also ask you which is the stage of product out of these 4 options for this particular reaction. Right now, so in that case, what is your option? So option is something, answer is like this. So we have that kind of product as option number 1 here. So this is your answer for the particular question. Okay. So now let me move forward. Yeah, before going to that, I just wanted to give you one more example question for your exercise. Yeah. Yeah. So for this, I am writing BR here, writing alcoholic KOH under heating condition. So what is the major product formed here? Very easy reaction based on the previous year understand, like previous year question, this previous discussion, you can answer this. Okay, so if this is alpha, identify beta positions. From that beta positions, you remove one beta proton, so you will get product. So what I told you, internal alkene is more stable, so identify which is internal alkene or more stable alkene, that will be our major product. Okay. Yes. Next, which are the following give fastest reaction with alcoholic KOH? Yes. So identify here, how can we answer this? Fastest reaction means the respective product should be more stable, then the reaction will be more fast, right now. So now here this is the alpha position which is attached, like wherever we have halogen, that carbon is alpha carbon, I can say. The adjacent carbons we can consider beta, and if this is alpha, beta, again beta, beta. Here this is beta, this side also beta. Like this you need to identify. So they are saying with alcoholic KOH, so always remember with alcoholic KOH mostly what happens, elimination takes place as I told you before. Okay. So like this you need to take. So if I do the reaction with this first one, so I will get a product something like this. From option number 1, here we have double bond, by removing this bromine and hydrogen from here, like this, we will get a product like this by removing this proton from beta position. Okay, this is from option number 1. So from option number 2, if I remove hydrogen, I mean protein from here, from beta position, using this base, we will get a product like this, right now. So what is this? This is benzene ring, which is aromatic, highly stable, right now. It means reaction will be more favored in the case of 2, because respective product is highly stable aromatic ring, benzene ring, so that will be most favored, or reaction is fastest is second one. So now I am not stopping my explanation with respect to this question itself. I am making it little more extension. So what I am asking you is, what is the reactivity order of these 4 options? Like which is more reactive, which is faster, and which is slower in this? How can you arrange them? See, I told you formation of benzene ring which is highly stable, therefore second option is like highly or most fastest reaction, and after this you need to look for the options of this products of other options also. What is the product formed here? So these are the beta positions. You can remove one beta hydrogen or proton, you will get a double bond here. So from here you will get something like this. Yeah, like this. Okay. See, here if you observe, this bromine is attached to the double bond. What I told you, so these bromines, like whenever we have halogen attached with the double bonded carbon, sp2 carbon, like this, like halogen can be chlorine, bromine, iodine, anything here. So they will be in conjugation with the pi electrons of this vinyl position. Okay, vinyl position. So therefore it will be inert towards the reaction, it won't participate in chemical reactions. Therefore this halogen will not show reaction or elimination with respect to this alcoholic KOH here. Okay, so we cannot remove this. So I can say this is slowest one here. So fourth one is slowest one. After this we need to look into these 2 options. See, we are getting it 2 double bonds in the first option which are at alternative position. So we can expect conjugation between them. So due to that conjugation they will gain stability. So first option, like product formed in the first option is relatively more stable than the 3. So I can write 1 and here 3. So this is the rate of reaction of this particular question. Hope it is also clear, right? Yes. So with this I will be winding up our discussion and I will be giving you few more questions as a practice. So take a screenshot of these questions and give a try from your side, and if you want answers for these, so just join our Telegram group. So I will be there in that. So just tell me your answer. So I will check whether it is correct or not. If any wrong, I will explain it. Okay, no worries. So thank you for watching. Stay connected with us. Thank you.